Well, there's some different triangles in the picture, so the first thing I'm going to do is make sure I know which ones we're looking for, so I know which parts count. R, oh, okay, two skinny ones. R to J to S, and let's see, R to K. So those two skinny ones, in the ends, we're trying to show those are the same. Angle 1 and 2, oh man, that doesn't count then. They're not part of the triangle. And let's see, JS. Oh, there we go. JS and KT. Those count. So that's one thing. So they gave us a set of sides. Oh man. Are we going to be able to get anything else? Gotta be able to. Actually, well, I'll tell you what. There's an isosceles triangle in there. And I think you're going to have to do linear pairs. So if you want to pause and try on your own now, go for it. But those are the two things that are a little tricky. Again, I'm going to just do it. But if you don't want me to just tell you, then you need to pause and try and look for those things. But I'm going to start with the isosceles triangle. I think that's going to be the easiest one. Where's your isosceles triangle? It's right down the middle here. I'm going to change back to black. Right down the middle, this triangle. Angles 1 and 2, those would be base angles. But the base angles are congruent according to the converse isosceles triangle theorem. The base angles are the same, and the sides of that triangle should be congruent. So that's segment RS and segment RT. And those correspond from the two smaller triangles, so that's a second set of sides. But that's it. The angles don't count because they're not in that triangle. So we've got to get a third part here. Oh man, okay, I think the idea here is that angle, okay, just hold on, I think you'll see this once I get it set up, but if not, just kind of ask a question if you need. We have angle JSR and angle 1. They're supplementary. And angle RKT and angle, angle right down here, this little guy, I'll mark it. Mark that first one too for you. So angles 1 is next, or angle 1 is next to RS. JSR is the way I named it. Angle 2 is next to KTR is what I want to say, KTR. And angle 2 are supplementary because they form a line. And that is the supplement theorem. And by saying they're supplementary, you know what we can do after that, I think. Could probably pause and see if you can get to the end from here. But we know that the measures are going to add up to 180. By the definition of supplementary angles, I can't hardly, my brain is going too quick. I know it, kind of excited to get it done now that I know what it is. I'm like, yes, I figured it out. I know how this is, I see how this is going to work. That's by the definition of supplementary. And if they're both sums are equal to 180, we can replace one of the 180s with the other sum. Oh, did you think something was just going to cancel out? It was going to be that easy? Well, you're right. Something is going to cancel out. It is going to be that easy, except not quite yet. I need to replace the 1 or the 2 so that will just be able to be subtracted from both sides. And you can't replace with congruency, so I've got another. I mean, that's why it's start. If you're sad that it ends up being too hard, what's the point? Right? Got to have a challenging one or two. So if you want it perfectly correct, technically, to meet the conditions of replacement rule, I need those measures equal. So we're going to change them to the measures being equal. Right? That's what it means to be congruent. All the measures are equal. So if angle 1 and 2 are congruent, then all their measures, which there's only one, is equal. And I can replace that big long equation. I'm going to rewrite everything the same all the way across from step 5. And all I'm going to do is when I get to the end, I'm going to replace measure of angle 2 with measure of angle 1, so that after replacing that in step 7, I can subtract the 1 from both sides and just get measure of angle JSR equal to measure of angle KTR, which those two correspond from the little triangles. That's my third set of corresponding congruent parts. Now they're not congruent yet, but again, with the angles, there's only one measure, and so to show something congruent, you only need, oh, almost forgot to put additive property of equality. I'm getting too excited here. When I'm subtracting measure of angle 1 from both sides. But don't forget, congruency, you need to show everything, all the measures, equal. Angles, there's only one measure, so put those kind of ideas together, and you show that one measure, you're good. That's your third set. Oh, shoot, tell me this is going to be a swear word. We're maybe still not done. I have 2 S's and an A. So we have a S, A, no, we're good. I think we still could have done it. We could have shown that this was an isosceles triangle maybe and done. We might have been able to do it yet, but we don't need to. We're good. We have the included angle, the angle that's in between. Now we got to look at the picture to know that for sure, but it's side angle side. 10 steps. It's only 10 steps. I'm going to name it just how they named it. So I got to scroll back up so I can see triangle RJS is congruent to triangle RKT. Hopefully you enjoyed that one.